Hello everyone, welcome to the boring lecture. Today, our boring topic is tossing coins. There used to be a person called Buffon who asked his son to toss coins thousands of times for him for his research in probability. Today, as we will see, we don't do this anymore. So, here is our setting today. We have 3 fair coins, but only one of them is normal. The first of them has 2 heads. The second is normal, having a head and a tail. And the third has 2 tails. Now, we randomly choose one of the coins, and without looking at it, we toss it, and we see that what's facing up is a head. Now we ask, given all this information, what's the probability that the coin we choose has 2 heads? Now, probably the intuitive answer that first came into your mind is just half, because we have eliminated the coin with 2 tails, and we have chosen the coins randomly, so there seems to be an equal chance of having the double head coin and the head-tail coin. But let's ask whether our intuition is really true. What we want to know is a conditional probability, or the probability of having chosen the double head coin given that a head faces up as we toss it. We can calculate this probability by the famous Bayes theorem. Probability of A given B equals the probability of B given A times the probability of A divided by the probability of B. Here, B is the event that head faces up, and A is the event that the chosen coin is a double head coin. Let's apply the Bayes theorem. By plugging in A and B as seen on the last slide, we have the equation shown here. Here, HH means having chosen the double head coin, and the word head just means a head faces up after a toss. You can pause here a bit and verify that this is the Bayes theorem. Now, let's plug in the numbers. The probability of having a head given that the double head coin is chosen is just 1, or 100%. Because however we toss the coin, we get a head facing up. And secondly, without any other information, the probability of having chosen the double head coin, or PHH, is just a third, because we have chosen the coins randomly. And lastly, what's the probability P head, or the probability of having a head after tossing the chosen coin? Well, if you think about it, choosing a random coin and toss it, it is just like choosing a face randomly among the 6 faces of the 3 coins. Because we have 3 faces that are heads and 3 faces that are tails, the probability of having a head is just half. Now, after plugging in the numbers, we know that the probability that we asked for is 1 times a third over half, which is equal to 2/3. And 2/3 is very different from our intuitive answer, a half. So to verify that what we have calculated is correct, I wrote a Java code to simulate a coin and a coin toss, shown here and shown on the next page. Now, on this page, I have basically written out our whole problem, which is we have 3 coins, head, 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 tail, 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 and we have chosen one randomly and we toss it. If it's a head facing up, we check whether our coin is the head-tail coin or the head-head coin. And I have run this code, and it says the probability of head-head chosen given a head toss is 0.666, which is very close to our theoretical answer, 2/3. Therefore, our calculation wins over our intuition. Yay! So you may ask, is there an intuitive explanation of the fact that the correct answer is higher than our original guess? Well, the basic idea is that although we have chosen the coins really randomly, we still need to modify our guesses or modify our models in face of new information. So in this case, the coin facing up heads not only tells us that the double tail coin is completely impossible, but also that the double head coin is more likely to have been chosen than the head tail coin. Actually, modifying our model in face of new information is exactly the process of Bayes analysis, a useful method for machine learning. Thank you for listening to the Boring Lecture. I am Hannah, the Boring Lecturer. See you next time.